Welcome to this explainer. There's a growing panic right now among technical leaders. If you've been working with generative AI lately, you've probably noticed it. Your infrastructure costs are scaling in ways that, frankly, feel completely alien compared to traditional software. AI tokens are rapidly becoming the massive new cloud bill. Today, we're going to break down exactly why that's happening and, much more importantly, how you can actually fix it.
We've got a lot of ground to cover to master AI token economics. We'll be looking at the new cloud bill, the multiplier effect, the AI waste stack, the optimization hierarchy, emerging AI FinOps, and wrap it all up with the strategic outlook. Let's jump right in.
Section 1. The new cloud bill, from CPUs to tokens.
Think about historical cloud spend for a second. It was always heavily dominated by vCPU hours, gigabyte hours of memory, storage, that sort of thing. Optimization was mostly just about right-sizing your instances and setting up auto-scaling. The foundational question was simply, how many servers do we need? But with AI-native systems, those cost drivers are totally flipped. Now we're looking at prompt sizes, massive context windows, and explosive agent loops. Instead of asking how many CPUs we're using, the new, much more complex question is, how many tokens are we burning per business transaction?
Section 2. The multiplier effect. Why tokens become dangerous.
So, in traditional cloud architecture, one user request usually equals a relatively linear path of compute. It's pretty straightforward, but LLM systems, they scale multiplicatively. When a user submits a seemingly simple prompt, it doesn't just ping a model and come right back. No way. First, it hits a planner agent. Then that triggers retrieval context to fetch data. Next, it might get passed over to a coding agent, verified by a reviewer agent, all before finally generating a response. It's like a massive hidden chain reaction.
To put that into perspective, a basic 500-word user request actually consumes over 28,000 tokens behind the scenes. Let's break that down. That's 2,000 tokens for planning, 10,000 for retrieval, 8,000 for coding, 6,000 for the review, and another 2,000 just for the final answer. The end user completely misses this massive engine churning away in the background. In traditional cloud terms, guys, this is the literal equivalent of spinning up 20 separate containers just to answer one single API call.
Which leads us to Section 3, the AI waste stack, where the tokens accumulate.
Organizations are waking up to discover massive bloat accumulating at every single layer of their requests. It is wild. Often 30 to 60% of token spend is literally just duplicated context being passed back and forth. Another 20 to 40%, unnecessary retrieval. It's like grabbing an entire textbook from the library when you only needed to read one single paragraph. And then 10 to 30% is spent on excessive rambling outputs. This is pure waste, and it is heavily taxing your infrastructure.
Let's fix this. Section 4. The optimization hierarchy, your 6-part playbook.
We start right at the top with context compression. Your absolute biggest initial return on investment comes from actively shrinking your context. By taking an unoptimized 10,000 token payload and compressing it down to a dense 500 tokens, you're looking at a massive 95% reduction in cost for that step. It's the AI equivalent of zipping a giant file before you email it. Just basic hygiene.
Step 2 is retrieval optimization. See, most retrieval-augmented generation, or RAG systems, aggressively over-retrieve data. By cutting back on that over-retrieval and focusing strictly on the targeted, actual context you need, you can frequently halve your costs. And the absolute best part, you usually do this with minimal, if any, loss in output quality. Step 3 is model routing. Look, you do not need to use a sledgehammer to drive a nail. You shouldn't send every simple little task to the most powerful, expensive model out there. By putting a router in place, you significantly reduce your inference spend. You can route basic classification to a small, fast model, use mid-sized models for summarization, large ones for coding, and strictly reserve those highly expensive frontier models for deep strategic reasoning.
The fourth step is output budgeting. Far too many applications waste expensive tokens by letting the model generate unconstrained long-form text when the user actually just needed a simple yes or no. Implementing strict output budgets stops your apps from wasting tokens on unnecessary, sprawling generations. It provides immediate, noticeable financial savings. Step 5 brings us to a whole new perspective on prompting. We have genuinely reached a point where prompt engineering isn't just about getting higher quality outputs anymore. It is literally cost engineering. A badly structured prompt can force a model into really expensive cognitive loops, while a clean, efficient prompt guides it straight to the answer. Good prompting is essentially writing highly optimized code now. Finally, step 6 is agent loop controls. This is arguably your largest hidden risk. To prevent autonomous agents from falling into infinite, crazy expensive loops, you absolutely must implement strict guardrails. You need caps on maximum iterations, maximum tool calls, hard maximum token budgets, and early stopping protocols. These act as the vital AI equivalent of traditional cloud resource quotas.
Moving on to Section 5, Emerging AI FinOps, Measuring Cost per Outcome.
The winning organizations out there are optimizing for real-world business outcomes, not merely raw token counts. In AI FinOps, success isn't just bragging, hey, we saved 1 million tokens. Success is knowing for a fact that your cost per automated support ticket is exactly 3 cents, or that your cost per AI-generated contract analysis is exactly $1.50. You have to measure the value of the transaction against the actual business result. If you can't attribute your token spend to a business outcome, you simply cannot optimize it effectively.
And in this mature FinOps model, context itself becomes your new storage layer. Just think about that for a second. Context requires rigorous governance now. You have to actively maintain running summaries, manage memory compression, enforce retrieval ranking, and constantly deduplicate data. Just like you wouldn't keep 10 copies of a massive database, you definitely shouldn't be paying to pump the exact same duplicated context through an LLM thousands of times a day. Finally, Section 6, the strategic outlook, the future of compute. Just as cloud computing once commoditized basic infrastructure, making servers cheap and accessible on demand, AI is now actively commoditizing reasoning. Intelligence itself is literally becoming a basic utility that you can just plug into your applications.
But, as we know, utilities still have physical and financial limits. The ultimate takeaway to remember from our explainer today is that context bandwidth, the exact amount of information you can realistically afford to move through these powerful models, is now your primary scarce resource. It is the bottleneck of the modern tech era.
Which leaves us with this final critical question to consider. Are you ready to measure, budget, route, and optimize your tokens as rigorously as elite engineering teams once managed their CPU cycles to win? The organizations that can answer yes to that question are the ones who are going to thrive in the new token economy. Thank you so much for joining me for this explainer, and I highly encourage you to go look at your own hidden AI waste stack today.